If you check the test of normality, and here is the Shapiro-Wilk test, its statistics value is 0.089, degree of freedom is 998, and significance value is 0.00, which is less than 0.05. Basically, we are testing at 95% confidence interval, so therefore our significance level, which is also called alpha, is 0.05. So here in this case, the p-value is less than 0.05, so it's a violation of the assumption of normality. We can check the histogram. You can see it's clear indication that there is no any symmetrical shape. The aim of this assignment is to analyze the set of data and then report the findings in a structured form. The learning objects are applied the concept of statistics inference to health research, applies stable statistical method to answer research questions in a variety of contexts, and study design demonstrate the ability to present, interpret, develop working. So basically, in this tutorial, we will discuss each and every point one by one. We are using a data that is in SPSS format. The variables are age, BMI, BMI6. BMI is basically body mass index at diagnosis. BMI6 is body mass index at 6 months after diagnosis. Duration of diabetes in years. FH type, family history of diabetes. Exercise, number of times taking exercise. NBLT test, number of blood tests. Insulin, at least one injection of insulin. These are the responses: 1 for no, 2 for yes, and comorbidity 0 for no, 1 for yes. So the tasks are basically these: A to G. What we have to do is use the data to carry out an appropriate statistical hypothesis to answer the following research question. These are the research questions. Wait a bit further. Okay, this is the data. These are the variables: age, BMI, BMI6, due diabetes, FH diabetes, exercise, NBID test, insulin, comorbidity, and up to so on. This is the template. Submission template. The first task is there a difference in age between patients who had a comorbidity and those who did not? We have to answer this. What is the null hypothesis? In this case, basically we are discussing a difference, so the null hypothesis will be H naught. In H naught we say there is no difference between mean age oblique median. Why I'm taking median I will explain later on. Mean age or median age, there is no difference between median age uh, median age between the patient having comorbidity or without having comorbidity. So this is the H naught, H1. There is difference between mean median age between the patient having comorbidity or without having comorbidity. Okay, so this is the hypothesis we have selected. In this case, which test we're going to use? Basically, whenever we are comparing the difference between two variables, so we have to examine the nature of the variables. So let's see in the data comorbidity. If we say comorbidity, here you can see the responses are 0 and 1. It means that it is a binary response variable. And age, if we see the age, that is a continuous variable. So this is the condition that whenever there is one variable that is continuous and the other variable is in a grouping variable which has binary response, in that case independent statistical test which will be used to examine whether the null hypothesis is true or false will be used is independent sample t-test. But again, it is linked with the assumption of normality. In case if normality is not fulfilled, we shall use main Whitney U-test. The reason to select the test is the factor variable is binary response variable. Okay. Assumption. The first assumption is normality. To check normality, we're gonna use Shapiro-Wilk test, QQ plot, and histogram. Let's move towards the SPSS section. Our dependent variable is age. We will check. Basically, we are trying to see that whether the average age is different for the patients having comorbidity or without having comorbidity. For this, we go to Analyze, Descriptive Statistics, then Explore, select Age here, and then go to Plot, unselect the stem and leaf, select Histogram, and then Normality Plots with Test. Continue, press OK. Here you can see Shapiro-Wilk test. If you check the test of normality, and here is the Shapiro-Wilk test, its statistics value is 0.089, degree of freedom is 998, and significance value is 0.00, which is less than 0.05. Basically, we are testing at 95% confidence interval, so therefore our significance level, which is also called alpha, is 0.05. So here in this case, the p-value is less than 0.05. So it's a violation of the assumption of normality. We can check the histogram. You can see it's clear indication that there is no any symmetrical shape. So it's a clear violation of assumption. Same as here, all the dotted points are away from the normal curve, the center line, and there is one outlier as well. This is the outlier. You can check this outlier, this is the outlier. To check the outlier, this is click here. It will take you to the value. Basically, this is a missing value 99, and that's why it shows it as a outlier. So ignore it. No problem as such. So finally, what is our conclusion? The conclusion is that normality assumption is not normality assumption is not fulfilled. So a main Whitney Q test is recommended. The other way test is the homogeneity of variance, or it also called equal variance. Let us check how this test is performed. For this, basically we will run one-way ANOVA. We are just running the one-way ANOVA to check homogeneity of variance, nothing else. Okay. Oh, sorry. Again, let me check one-way ANOVA and options, homogeneity of variance. Click OK. Here again, if we see the Levine statistics is 1.850, degree of freedom is 1 in 996, significance value is 1.174, which is above the significance level, that is 0.05. So we have enough evidence to reject the claim that there is no homogeneity. Basically there is homogeneity and the assumption is not violated. But again, what happens if normality assumption is not met? If normality assumption is not met, then the statistical results are not reliable. That is the reason we shall be using non-parametric test, which is the main Whitney U test. Remember, whenever the independent sample t-test is uh, failed, like the assumption of independent sample t-test are not met, then we must have to use the non-parametric test, and the alternate to independent sample t-test is the main Whitney U test. So the second part is what are your results and conclusion. Remember that we have to use a PS style. Results should be in APA 7th edition. So let's run how the main Whitney. Let's first run the independent sample t-test. For the independent sample t-test, what we do is basically we go to analyze, compare means, and then independent sample t-test. Select the dependent variable, that is also called the test variable, is age, and the factor or the grouping variable is the grouping variable, that is comorbidity. So we have to define its levels. For that we have to check the variable section. Basically we have to use its codings. It's 0 and 1. Basically these are 0 and 1 binary codes. We have to group 1 has 0 codes and group 2 has 1 code. Okay, so sometime there are no codings and still you are interested. So at that point you must be given with some condition, like 50%, like 50% on group 1 and 50% on group 2. At that case you can use cut point, you can write here 50. Okay, but here we are using this condition. Press OK. Okay, all right. So the results for t test is the test statistics is -2.36. We are using equal variance assumed because the Levin's test is insignificant, and -2.326 and significant p-value. This part we are using basically uh, 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 because we are interested in 95% confidence interval. So the p-value is 0.02, which is less than 0.05. So it means that we have enough evidences to reject the null hypothesis. When we accept the null hypothesis, when this p-value is above 0.05. But we have already discussed that the result may not be reliable, so we are using the non-parametric test. For that we go to analyze, and then non-parametric test, and then legacy dialog, and then independent sample t-test. Here you can see man Whitney you test, check it. The process is almost same. Comorbidity, define group 0 and 1, continue, options, we don't need descriptives, just press OK. Again you can see the main Whitney U test is also significant, uh, the mean rank, but just you have to write in your writing that instead of mean you can say mean rank or significant, because the p-value is less than. So now write the results. The test statistics used in this case is the main Whitney U test. The test results indicated indicated a significant result. So we have to write the significant result here. So man between U test is usually noted by W, but we have to write these notations in italic. And the degree of freedom, there is no any degree of freedom for main utility test is equals to W is equals to you have to use this value. And sorry, uh, sorry, two decimal points always. And P is less than 0.05. P is less than 0.05. Okay, this should be, but the numbers don't need to be in italic. Only the uh, test statistics notations should be used in italic. It shows that for the ES7 style, the writing should be times in Roman and 12 size. It shows that there are enough evidences to reject the null hypothesis of no difference. It can be concluded that mean rank, so average age of the patients, is different, is not same for the patients having comorbidity, comorbidity and without comorbidity. So this is how we completed the first task using SPSS. In the next tutorial I will explain the second task, that is still a difference in the number of blood tests between patients who had a comorbidity and who did not. See you in the next video.